Wrapped up our trebuchet competition where it took us about 6 weeks to get here. We built 12 trebuchets, 6 per period, and I just want to walk through a little bit of kind of the lessons learned that I had with it. Number one is some of the physics attached to it. So the design was pretty open for kids. We had set form size for our concrete blocks. We designed and 3D printed these braces to hold the pipes in place. One thing that I didn't specify for students was the beam length. And so we had, again, some students that put that more in the middle. And then you'll see we had to actually adjust where that counterweight went, because as this starts to tip, the center of gravity overcomes the midline and it actually falls over. So I think next year I need to really specify what that distance should be. You can see if we walk over to this one, right, we have that pivot point is set much more towards the end of the board, right? And that this, as it swings, isn't going to be as unstable and won't tip over. The other lesson learned is we did a bunch of prototypes out of cardboard. I don't know that that was worth the time and effort, because students still had some real conceptual misunderstandings of how the trebuchets worked by the time we got to the actual build. So I might take that out next year. It's a nice idea of an introduction, but they still struggled. One of the things that really makes a difference is the quality of the sling. So we use grocery bags and basically form them into slings. The teams that did the best really took the time on two things. Number one is, this one was a good one, to really form that sling to hold the projectile. And then the really critical part is the length of the rope. And so being able to have that length so that you have equal tension as it is coming through. All right, the last piece that I didn't anticipate, but that we struggled with a lot, was what to actually try to shoot. And so we have a variety of different balls that we used. We used mini basketballs. For the most part, those work really well. But we have to find something that is heavy enough to actually release the sling. And so actually kind of what we came up with as a good alternative, but this is a kickball that's then filled with sawdust. And that actually works pretty well. It has enough weight to it to release the string. But the other piece is, obviously we didn't want to, if somebody actually got hit with the ball, we didn't want any injuries. So trying to find something that worked well and was safe. And so when we ran them yesterday, for the most part, very successful. We did have 4 of our baskets from the half court line of the basketball court actually go in the hoop. So that was pretty cool. But it's a good project. I enjoyed it. Putting it on casters this year to be able to move it down was a nice addition. And I'll just iterate on it again next year and hopefully continue to kind of clean up the project. And students really liked the kind of scope and scale of it, as well as the open-ended design piece.